This lesson is 2.3. We're going to solve absolute value inequalities. So in the previous one we solved equations. We're going to switch it now to an inequality that actually makes a pretty significant change to the problem. Okay, I want to review graphing inequalities that you must have done maybe in 7th or 8th grade math, would be my guess. Okay, so can we review how to graph inequalities? There are two words that go with inequalities, the word or and the word and it changes completely your answer if you have the word or, if you have the word and what we need to come up with then is a way to figure out with absolute values, when do I use or and when do I use and you got to know what they mean. So let's review what they mean. If I ask you to sketch on a number line this, okay, so sketch this, x is less than -2 or x is greater than 5. It may have been a couple years since you guys did this, so let's review what that means. I want a number that's either less than -2 or greater than 5, and I think you probably could come up with one. Like if I asked you, is 6 either less than -2 or greater than 5, would that be true or not? Is 6 either less than -2 or is it greater than 5? That's true, right? Because it's bigger than 5. Is 0 either less than -2 or bigger than 5? No. Okay, and maybe doing that just spatially like this, I can't figure out, I don't know. If we set up a number line, that really helps us see this. Okay, so what I'm going to suggest on your number line, put the numbers in order. Okay, -2 would come first, 5 would come second. And then we're going to sketch these based on this inequality. If x is less than -2, since there's no equal sign, I'm going to put an open circle at -2, and then it's either everything to the left or everything to the right. What would it be? Less than should be which way? To the left. Okay, so everything in here would make that inequality true. X is greater than 5, again there's no equal sign, so I'm going to put an open circle. Greater than would be to the right, so everything over here would make that inequality true. Okay, since it has the word or, it's true. It just has to be true for either one. It doesn't have to be true for both. So all of that is my answer. Okay, that is anything here, anything here. So I'm going to darken that. That would be my answer. All right. So 6, yeah, 6 is true. 0 would be here. No, that's not true. -4, yeah, that's true. Okay, now in inequality interval notation, I feel like it's so nice. Interval notation is nice because right here I would say the answer is from -infinity until -2. And I would put parentheses because it's always a parentheses with -infinity, right? And I got an open circle at -2. Union, you guys, that's or. That's or. Okay? Pick it up at 5, go to infinity, parentheses with both, that's the solution. Okay? That's the solution in interval notation. This is the solution graphically. Okay? Now, if all I did was change one word there, change it to and, that makes this a completely different problem. If I ask for when is x less than -2 and x is greater than 5, that's the same as me asking you, give me a number that's both less than -2 and bigger than 5. Can you give me a number that's both less than -2 and bigger than 5? Is that possible? No, and again, if you looked at the graph, this would still be the graph here, but because of the word and, I'd have to say there is no solution. The and, you guys, is the overlap. What's the part where these graphs overlap? Where do these graphs overlap? They don't. So this would be no solution, okay? Changing that word to and makes all the difference in the world. There'd be no solution because of the word and. All right, what about this? What if I switch this inequality and I made it a sandwich? -2 is less than x is less than 5. This actually, we call that a sandwich. We combine it all into one, and you'll notice in the middle of the word sandwich is the word and. This really is an and statement. It's both of these where x is bigger than -2 and x is less than 5. Okay, so this means it's a short way. Again, math has all these shorthands, right? This is x is bigger than -2 and x is less than 5. Okay, so I switched the inequalities. But this, seeing it here, if I was going to graph this, I would go from -2 to 5. And again, say I had come up with the solution here. This is what it's going to look like when you're solving these. It's going to start like this. And so you're going to do this part first. You're going to say x is greater than 2 means put an open circle at -2. Sorry, -2. And greater than would be this way, and I'm going to make it really light. Because of the word and, I'm going to make it really light to begin with. And it keeps going on and on. X is less than 5 would be to put an open circle here and then go left. This would be less than 5. And then because of the word and, I would shade darken this. That's the solution. Okay, and which I can see, that's what this is. It's everything between -2 and 5. That's the answer to that. Okay, writing this in interval notation, we'd go parentheses -2 to 5, close the parentheses. Okay. So that would be an and where it was everything in between -2 and 5. Okay. All right, we're going to go now to the absolute values and see how this all applies to what we've been doing. So number 2 here, Roman numeral 2, we're going to solve absolute value, abbreviate that, ABS value inequalities. Okay? And we're going to do this first graphically, and then we're going to try to come to some conclusions analytically by this. Okay? So first we're going to do the same thing as we did before, but we're going to graph F and G, a graph. Then they're going to add one little extra thing because it's going to be an inequality. All right? It's going to say this, highlight. It's going to tell you one of them. In this case, I'm going to say highlight G. Okay, and it's going to alternate back and forth. Sometimes you're going to highlight F, sometimes you're going to highlight G. Okay, so highlight G where, now, however they write this, f of x is less than or equal to g of x. Here's what I want you to do. I want you to rewrite that inequality so that whatever you're highlighting is always first. Okay, because for me it's easiest to think of it that way. So if I'm going to highlight G, I want to put G first. G is on the side that's greater than. So if I switch these and put G first, I would need to write it that G is greater than or equal to F. Right? Okay. So I'm going to do that. I realize I forgot one thing. We're going to go ahead and finish this problem, then we're going to come back and add something here. Just a second. Okay, number 1, I want you to graph F is the absolute value of x, and G is 3. Okay, so F is the absolute value of x, and G is 3. So set up an x and y axis. Absolute value of x has not been shifted at all, so it's just right here, 0, 0. This is the parent graph with a slope of 1. So I'm going to go up 1 over 1. And I'm going to label that F. And then I'm going to label graph G equals 3, which is a horizontal line up at 3. Extend it beyond here a little bit. Call that G. If you have a highlighter, you can use it. If not, you can just kind of shade a little and darken a little what we're going to do now. Because after you have this, you guys, here, we're going to highlight G. Okay, so G is the horizontal line, so I'm going to make my highlighter on that. It gets a little tricky because you're going to bounce back and forth. Sometimes you're going to highlight the V, sometimes you're going to do the line. Okay, so this is why I wanted you now to put G first. I want to highlight the line where G is greater than F. Okay, so focus up here, you guys. Where G is greater than F would be where G is above F, right? Okay, so here's G. In here, is G above F? In here? No. Here, in this area, is G above F? Yeah, it's above F until I get to right here, right? And then from here on, G goes below F. So I'm highlighting G, which is the horizontal line. So if you have a highlighter, if not, just take your pencil and kind of make this darker right in here. What we have just done is solve this particular inequality, okay? And so the x values here, what we would say, it's going to ask you to go g of x is greater than or equal to f of x. And it's going to give you, I think it says over or along the x-axis is what it's going to say. And that's going to give you a big line. And what they want you to do is put in interval notation, where is g greater than or equal to f? Okay. It's equal to f right here. It's greater than in between. Okay? So I would write this answer as -3 to +3, and I would include both of those. So it's going to be a bracket, -3 to +3 bracket. That's where g is greater than or equal to f. And I put brackets because it had an equal sign, right? Okay, now, this right here, you guys, is what I would call, yes? Along the x-axis, it's going to be in the directions. It says state the interval along the x-axis. You'll see on the worksheet. Okay. All right, so now we're going to do it algebraically, and this is where the tricky part is. Okay. I want to know where is g greater than f. And so I'm going to take g, which is 3, and I want it to be greater than or equal to the absolute value of x. Now I'm going to switch it back around. Absolute value of x then would be less than or equal to 3, right? Okay. As we learned with the equation, there's two scenarios here. One is with a +3, one is with a -3, okay? But the key is I want to end up with the answer being between -3 and 3. Okay, how could I possibly get that? I want my x value to be bigger than -3, but less than 3. Okay, so here's how you would write that. The first case, you always can just drop the absolute values. That's a beautiful thing. You can always just drop it. One of the answers is always going to be this. But the other answer, what really ends up happening is I make this a -x, and then I divide the negative over, and this is what I forgot to talk about before. Who remembers with an inequality, if you divide by a negative or multiply by a negative, what you have to do? You got to switch the inequality. Do you remember that? I think you did in 8th grade math. Okay? So we got to switch the inequality. So instead of it being less than, it's going to be greater than. When I change that sign, and it's because I'm changing the sign, I'm dividing by a negative, that I have to switch that inequality. Okay, this right here is this sandwich. It's between -3 and 3. If I graphed this on a number line, I would put -3 and 3 on the number line. X is less than -3. I would do really, really lightly. I'd put a solid dot in this case because it equals, but it would go this way, right? X is greater than -3. I would do really lightly. It would go this way. And then we want everything in between. What was the word that had to go in between where we did the overlap, where we wanted what was true for both? Was that or was that and? That was and. That's the word that needs to go in between here. Okay, now here's how you're going to figure out what word. If I don't graph it, how would I know that? Here's how you're going to figure that out. Okay, listen, you guys, this is the steps. You've got to get the absolute value all by itself, and it needs to be on the left-hand side. Then you're going to look at this inequality. If it is a less than, what I like to think of is less than, that's the word you're going to put in between. It's the word and. So with this is all by itself, then what you're going to do is you're going to say less th, and I write it an, and I throw the and at the end. Less than means you need the word and in between, because that changes the problem, right? If it's and or if it's or, those are different problems. So if it's a less than, you're going to put the word and in between. If it's a greater, guess what word you're going to put in between? Or. Yeah, so let's show you one of those. Hey, can we just make note up here? I told you I wanted to do one more thing up here, and that was if I did negative 2x is less than 6, if I divide by a negative, just review those notes, divide by a negative, you have to switch the inequality. And if you played around and you plugged some numbers in, if we had time I would do that, but we're a little short here. So, but you guys know that already. You know that rule, right? Anybody never seen that before? Okay. All right. Another example of this, number 2. If f of x is equal to the absolute value of x minus 1 and g of x is 4, highlight, in this case, f, where f is greater than or equal to g. I like the way this is set up because the one I'm highlighting is first, and that's what I would always do. I feel like that's easier to visualize. Get the one that you're highlighting first. Okay, so let's graph this. We ready? Set up an x and y axis. Okay, which way are we shifting this graph? Which way? Right one. Okay, so I'm going to shift it right one right here. And then it has a slope of 1, so I'm going to go up 1 over 1. We'll call him F. All right, and then graph g of x equals 4. If you haven't done that already, extend it beyond. Okay, and label g. Okay, now we're going to highlight f. F is the v. So we're going to either, we're going to be highlighting portions of this. I want to know where f is greater than g. Okay, ladies, please. Where f is above g. Okay, so here as I'm comparing these, this is f up here, right? This is g. Is f here greater than g? Is it above it? Yeah, so this is part of where f is greater than g. So I'm going to plot that right there. But here now f is beneath g, so I don't want any of this. But what about over here? It's also greater, right? So I'm going to highlight that. That's going to help me figure out the answer to this. So along the x-axis, the interval along the x-axis over which this is true, well, this will continue to stay above, right? So it'd go from negative infinity, right? My lowest x value would be negative infinity up until this point. What was my x coordinate right here? Negative 3. So the answer to this would go negative infinity to negative 3. Would I put a parentheses or a bracket with a negative 3? How do you know? Bracket because it's equal. Okay, and then this is a union case, which means what word should go in between? What was this? You remember union was or. Union's or. What's over here? 1, 2, 3, 4. We'll pick it up at 5, and it'll go on and on and on forever. That's the solution, okay, for that. Where we're going to live most of the time now is this next part. Algebraically, I want to know where is f of x greater than or equal to g of x. Where is the absolute value of x minus 1 greater than or equal to 4? Okay, so again, the first step, these are kind of easy because the absolute value already is isolated, but you got to get it all by itself first. Do that first, then look at the inequality. Okay, since it is greater than, that's the key. Greater. That's the word you got to put in between, and it makes a big difference if you put an or there, right, as opposed to an and. So one of the solutions is just drop the absolute value. Okay, put the correct word in or, then you're going to change this sign, but what else are you going to change? I'm going to change this to -4. What else do I need to change? Yeah, got to make this less than. Otherwise it won't work. Okay. All right, add the 1 over. We got x is greater than or equal to 5, or x is less than or equal to, add the 1 over. What's -4 plus 1? -3. Okay, so you're going to get to this point and they're going to ask you to graph it. If I graphed this, put them in order, -3 would come first, 5 would come second. If I graphed everything greater than or equal to 5, I'd put a big solid dot at 5 and I'd sketch everything to the right. If I graphed everything less than -3, I'd put a big solid dot at -3 and I'd sketch everything to the left. And then because it had the word or, that means it could be true for either one, so I'm going to take both of them. And that would be from -infinity to -3, union 5 to infinity, which is what we got when we did it graphically, and we should get the same answer. Okay, I want to do a couple off the homework. You only have 14 to do. Let's do a couple to kind of finish our notes here rather than drawing all these. Let's do a couple of these. Okay?